Hello. In this video series, we're going to be taking a look at applying Newton's first and Newton's second law of motion to various scenarios that have shown up on different AP exam questions. Let's take a look at number one. Number one says a mass hangs on a rope and is accelerated upward. Well, if we look at the general picture, and if you have not completed the picture, pause the video, draw the picture, and we will resume. Now that you have the picture drawn, let's take a look at the basic forces that should be involved. We need to be applying forces such as an applied force to an actual push or pull on an object, tension to a force on a pulled rope or string, weight. Well, weight means gravity, and that's always at work in any problem. Friction. You must have a rough surface, and you must be either moving or attempting to move on a rough surface in order for friction to be at work, and friction always opposes that motion. Normal force. Normal force is the surface force. It's the force applied from the surface perpendicularly onto the object. Normal means perpendicular. And lastly, spring force. Spring force is the force to pull a spring or to push a spring, stretch or compress a spring. Weight has an equation. Make sure you write it down every time you reference it. Friction has an equation. Make sure you write it down when you reference it. And spring force also has an equation. We'll get to the spring force equation when we need to use it. In number one, the mass was accelerating upwards. The only forces at work in this problem would be the tension going up and the weight going down. That would be good. Now you can write weight equals mg. Some students like to write Fg for gravitational force equals mg, or you could just simply write mg. That would be fine too. I tend to write it this way more often than not. In the next box, we're going to draw what the free body diagram should look like. We're going to draw a force going up, label it for tension, and you're going to draw an arrow going down for weight. The most important part about this is since you are accelerating upward, your tension has to be longer than your weight. So just make sure the tension is drawn longer. If you were moving with constant velocity or you were at rest, you would make the forces equal to each other. But the force that is going in the direction of acceleration is always the causing force, and that is longer. We're going to apply Newton's second law. Okay, now Newton's second law is written as net force equals ma. However, we can simplify that to causing force minus opposing force equals ma. Now in this particular problem, the causing force would be your tension, because tension is pointing upwards, acceleration is upwards, therefore tension caused the acceleration. So we would replace causing force with tension. Minus, why do we subtract? Because opposing forces go in the opposite direction. The opposing force would be the weight. The opposing force to acceleration would be the weight. We accelerate up, but weight points down. Therefore, tension minus mg equals ma. This would be the equation to model the upward acceleration of that object in number one.